Hello and welcome to this second video on the IBM expansion unit, where we'll be using the full capabilities of the expansion unit by throwing in a dual screen setup, a pointing device support, multimedia speakers, some network connectivity, and beyond. So as you can see, we still have a lot of room in the expansion unit, and we are going to be using that room to add all kinds of goodies. And we're not going to be adding expansion cards just for the sake of adding them. We're going to do something useful with them. Like this memory expansion card, color graphics adapter card, XTID card, networking, I/O, and sound. So let's start the PC, and at first you will see that there is an 1801 error being displayed. Now this is because the PC has an extender card installed, but it's unable to find the expansion unit. So nothing is hooked up at the moment, so that's why we are getting this 1801 error. But the PC should boot fine, and it should boot off a floppy drive now into MS-DOS version 6.22. And then we can load up, check it on another floppy that I have here to look at the system configuration. Now, if we load up the system hardware configuration, we see that the machine has a base memory size of 256 kilobytes of RAM, that we have 180 by 25 mono video mode, and there are two floppy drives, a parallel port running at address 3BCH, no COM ports, no game ports, no mouse, no clock, just the basics. Now moving to the interrupt assignments, where we have an overview of the available interrupts and DMA channels. Now IRQs, or interrupt requests, are made available on the ISA bus via this D8259 programmable interrupt controller. The IBM PC also has a direct memory access controller provided by the Intel 8237 chip, offering 4 DMA channels. We have 8 interrupts, 2 of which are already used by the system timer and keyboard, and an additional 3 are already taken up by the basic components in the IBM PC XT. IRQ5 is used for the fixed disk. IRQ6 will always be used for the floppy disk adapter, and because we have an MDA graphics card installed, which includes a parallel port, IRQ7 is reserved for the first parallel port. In terms of DMA channels, we have 4 DMA channels on the system. DMA 0 is the refresh DMA, which is not available. DMA 2 is used by the floppy disk, meaning that we have 2 DMA channels available, DMA 1 and DMA 3. Now here we have an ISA memory expansion card with 3 banks of memory. In total, this gives us an additional 384 kilobytes of RAM. So as you can see here, we have bank 1, bank 2, bank 3. We have a dip switch here to enable the individual banks. Now, before we continue with the expansion card, we need to ensure that the main board is set up properly. And there are 2 switch blocks that relate to memory settings. Switch block 1 has 2 switches, switch 3 and 4, which tell the motherboard what banks are currently populated. Switch block 2 on the IBM 5150 mainboard tells the system how much conventional memory there is. So this includes both mainboard memory and memory found on expansion cards. So in theory, this should give us 640 kilobytes of RAM, because we have 256 kilobytes of RAM on the main board and 384 kilobytes of RAM on this expansion board. But I was only able to get it to work with 576 kilobytes of RAM, oddly enough. Now, if you misconfigure these dip switches, strange things will happen. Either you will see garbage like this popping up on the screen, or you will see 201 memory error codes upon startup, or the system will hang. So you need to ensure that these dip switches are set correctly. Now, the second card we'll be installing is this CGA card from IBM, allowing us to hook up an IBM 5153 CGA color monitor. And this is really cool because this not only gives us color and graphics, but it also allows us to use two monitors pretty much at the same time. So the CGA card here has a standard monitor output, but also an RCA output for composite. So we'll install that one. And with that, our PC is completely filled. So there are no more free expansion slots here. And here we have check it loaded. So let's look at the installed hardware. So here we can see it has detected 576 kilobytes of base memory, so not the full 640. If anybody has any idea why this doesn't work on this expansion card, please let me know, because the expansion card works fine in another IBM I have here. Another thing we notice is that besides the mono video adapter, we now also have the CGA color adapter, which is detected here. All the rest has remained the same. Also on the interrupt level, nothing has changed because both the memory card and the CGA card don't require any interrupts. But now it's time to hook up our expansion unit once more, because we have run out of expansion slots on the IBM PC, and more importantly, this portion of the PC doesn't have a hard drive, making it very difficult to run software on it. So we'll go ahead and close up our IBM PC, hook up the IBM expansion unit, and start it off from there. Now I'm just going to be using the IBM expansion unit here as a very expensive monitor stand, because you don't need the expansion unit to hook up two displays on your IBM PC. Now this one is configured now to use the MDA card as the primary card, so we'll boot up MS-DOS using the monochrome display, but we can use the mode command to switch between the MDA card and the CGA card. Notice now that we have a prompt on the CGA monitor where we can enter commands, and as we're doing so, the monochrome display is completely frozen, so you cannot use two displays at the same time, as it were, because only one of them will accept input from the keyboard here. And we can use the mode mono command to give control back to the monochrome display so that we can enter commands there. Now, as cool as it is to switch between these two screens using the mode command, things get really awesome once you use software that is optimized for using two screens. And one of these pieces of software is Lotus 123, where in the main setup menu you can configure your screen display to use two monitors, and that means that you can use one monitor for your basic input and then use a secondary display for displaying graphs. So this is what we're going to do now. So I'm just going to start the application here on my monochrome display, where I have a high resolution monochrome display to enter text and numbers. So we'll go ahead and fill up our sheet with some numbers here. I'm just going to quickly add a little data set here and then go into the graph menu, where I will select my x-axis as well as the first data set here, which is just 4 numbers, and then I can display the graph on the secondary screen. Now obviously this is a black and white graph, but Lotus supports color as well, so we'll go ahead and add that. And we can even make it even more funkier by adding a second data set and really bring this CGA palette to life. Now I also wanted to show you Check It, where we see that the fixed drive has been found, the 10 megabyte MFM hard drive. And when we load up the interrupt assignments, we see that although none of the interrupts has changed because IRQ 5 was already reserved for the hard drive, we now see that DMA3 has been reserved for the fixed disk, which was not the case previously, as it was not present. Now, another useful feature to add is this XT IDE card, which allows you to expand your storage with more modern storage items like compact flash or SD cards. So this one uses a SD card to compact flash adapter, and it uses the XT IDE Universal BIOS, which is put into this ROM here. Now, a little note on the I/O address and ROM memory address selection here on the back of the PCB. If you have an existing MFM controller, most likely it's going to use the C8000 address, so you don't want to set your XTIDE adapter to that address. Also a note on the I/O address selection, because the I/O address is located in two places. One is determined by these dip switches here, but it's also hard-coded in the XTIDE Universal BIOS binary. Now you can configure this binary using the XTIDE config tool that you see here, and you need to go into Configure XTIDE, select Primary IDE Controller, and there you will see the same I/O address, and that needs to be set to the same value as the one which is set via the jumper settings on your XTIDE card. Now there's a bunch of other stuff that you can configure here in the XTIDE BIOS, but we're not going to go into detail on that. I'll do a separate video on the XTIDE cards and setup and configuration and whatnot. So for now, we're just going to install our XTIDE card alongside our MFM controller, and everything should work fine. So the first thing you'll notice when launching with the XTIDE card is this splash screen. Now, by default, it will boot off the C drive even if there is a floppy disk installed. And the C drive here is the original MFM hard drive. This is not the compact flash card which is installed. The boot order is something that cannot be configured here because the boot menu is not enabled in this version of the XTIDE Universal BIOS. So you'll get the MFM drive as the C drive here. Now, because we have MS-DOS 2.0 installed on this MFM hard drive, it won't be able to read the compact flash card simply because it is unable to interpret the partitioning information on the compact flash card. So it can read its own hard drive, obviously, but when we select the next disk drive, that it does detect, but it's just unable to read the partition. It marks it as a non-DOS partition. So how do we fix this? Well, we boot from a floppy disk by hitting the A key as soon as we see the splash screen, which will trigger the XTIDE card to boot from the floppy instead of the hard drive. And on the floppy, we have a version of MS-DOS which is high enough to read both the MFM hard drive and the compact flash card. As can be verified here by fdisk and see both hard drives just fine. Now, another useful feature to have on a PC is a pointing device like this beautiful Logitech mouse here that I have, which is a standard serial mouse. But as our IBM PC doesn't have any serial ports at the moment, we will need to provide an expansion card for that. And I just happen to have this 8-bit expansion card here, which has a serial port. It also has a parallel port, a game port, and a second serial port. But we're going to be disabling all of those because we only need the one 9-pin serial port. And we'll configure that using these jumpers here. Now, luckily, I was able to find the type of this card and look up the documentation so that I knew which jumpers to set in order to only enable the COM port. And let's take a look at this documentation. Unfortunately, my printer crapped out on me just at this moment, so excuse me for the bad text. But as you can see here, we have two serial ports. We have a parallel port. Serial port A is exposed here. Serial port B is exposed via these headers. And we have the parallel port, which is also here. Now, we're going to be specifying serial port A as COM1. So we need to short jumper number 1, which I did right here. Now, if I wanted to disable the serial port A, I would have opened up all of the jumpers. But we didn't, so we'll need to set an IRQ for the serial port, and I've opted for the default IRQ 4, meaning jumper 13 needs to be shorted. Now, because IRQ lines are scarce in this IBM PC, I went ahead and disabled the parallel port and the second serial port on this expansion card. So let's go ahead and add this to our expansion unit and load up Checkit. Now for this, I'm going to be moving to Checkit version 3 as it offers some additional functionality in terms of really seeing what's inside your computers. So we're going to be loading up our configuration here, and notice that we have a serial port right now, which is COM1, living in address 3F8H. Now the COM port not only needs an address, but it also needs an interrupt. So it has been assigned IRQ number 4 per the jumper settings that we did on the I/O card. So we only have 2 available IRQs left. Now another cool feature of Checkit is this memory map feature, which allows you to really see inside your conventional and reserved memory. So one of the first things we see is the MDA video RAM located at B000. This is coming from the MDA video card. We also see the disk ROM at C800H, which is the BIOS on the MFM controller. The DE00H address is used by an adapter ROM, which is our XT IDE controller card. So here you can see that there is no conflict between the MFM card and the XT IDE card. But now back to our COM port and our mouse. Now, despite the fact that we have attached our mouse to the serial port, the Checkit application doesn't find a mouse, so we are also unable to test it. Now, before we can start using it, we need to load up a mouse driver in MS-DOS, and a very popular one is the Qt mouse driver, which finds the mouse on COM number 1. It has detected that it's a Logitech mouse, so all is well. So only now can we go into Checkit and verify that the mouse actually works. And this will actually also test the IRQ associated with the COM port, because without a valid IRQ, it is possible that your mouse is being detected, but that your mouse simply would not work, that the PC would not be able to respond to mouse click events or mouse movements. Now the next card is extremely difficult for me as it contains the number 3. And I have a tendency to pronounce 3 as tree. So this is a 3COM networking interface card using this BNC style connector, released in 1991, so not entirely period correct, but I mean, these 8-bit networking cards are pretty rare, and I'm just happy to have found this 3COM card. Now, all of the configuration is done using jumpers here. So you set the I/O address and the ROM memory address using these jumpers here. You cannot set the IRQ using the jumper, so that was something that I found odd. But let's go ahead and install that and see how we can configure it. Now, my recommendation is always to pick up a networking card with great driver support, and this 3COM card is excellent in the driver department. There is this Etherlink 2 diagnostics application here that you can use on an XT to do some diagnostic tests. Unfortunately, although I am able to see the various configuration like I/O address, memory base address, and the MAC address of the networking interface card, as well as the IRQ and DMA channel, I am not able to perform any kinds of tests on this card, as the computer just craps out with this parity check 1. This did work on another XT clone that I have, so I don't know if it's somehow related to bad memory in this IBM PC. There were some 201 errors popping up from time to time, so I'm going to go with that idea for now. But what I can show you is the impact on the interrupt assignments. And oddly enough, IRQ3 is still available. So what gives? Well, IRQ3 will only be detected by Checkit when we load something that is actually using the networking card. So a popular way of interacting with the networking card in MS-DOS is through a packet driver. And I happen to have this 3COM packet driver here, which you need to initialize with a software interrupt, which is 0x60. You provide the IRQ, which is 3, and you provide a base address, which is 350. Now, with the packet driver loaded, we can use mTCP, which is a TCP stack for MS-DOS. And we do that by setting the mTCP CFG variable, having this point to our configuration file. And then we can execute a ping, for example, to a Windows box that I have here sitting on my network. And as you can see, the packets are being received perfectly. Now the way that this works is that mtcp uses a config file, which in this case is called tcp.cfg. And when we look at the file, we'll see lots of defaults, but the important thing here is the packet software interrupt, which was used by our packet driver, and the static IP address here, which is a valid IP address in the network here. Now with the packet driver loaded, if we now look at the interrupt assignment, we will see that IRQ tree has been assigned to the tree C503, which is in fact the packet driver that we have loaded. Also note that in the base memory map, you will be able to find the ROM address of the networking card, which in this case is CC00. So you can also use that to ensure that there are no conflicts with other memory addresses. Now you don't have to use 8-bit networking interface cards on XT-based machines. There are plenty of 16-bit ISA network interface cards that will work perfectly fine with your IBM PC. Your mileage may vary upon different models, but I have had luck with quite a few of them because the 16-bit portion of these ISA connectors are typically only used for either setting up the networking card or interfacing with the ROM. So yeah, you don't need to have an 8-bit ISA card. Moving on to the multimedia section, where we have this 8-bit sound card, which is a soundblaster clone of unknown origin. So the cool thing about these things is that they are completely configurable using jumpers. So you can set the IRQ, IO, DMA, enabling or disabling the game ports all via jumpers, so that's a really good thing. We're going to be using IRQ2 here because this is the only IRQ which is still available. Luckily there are still some IO addresses to choose from, including the default 220, so we're going to go with that. And the DMA channel that we're going to be using is 1. So let's pop this one in and install the drivers for the sound card. Now you can use the standard Creative Soundblaster 2 drivers or installation program to get this card up and running, but it is a gruesome experience in terms of speed. I mean, this has to be the slowest application that I have ever run on my XT, and that basically says a lot. This took almost half an hour to install the Soundblaster drivers on this XT. It's obvious that this installation program was not created for an XT class machine, but it does work to some degree in the sense that you will be able to get all of the files installed on your XT, change your autoexec.bat and config.sys file to load up the drivers. The only thing that won't work is the diagnostics program to play back these sounds, which for some reason doesn't work on an 8088. It does detect the sound card. You can auto detect the base IO address, IRQ, DMA, but then it just hangs just before it attempts to play back any sound. Now, because the setup program was too slow, I was slamming the enter key a little bit too much, so it configured the Sound Blaster with the default IRQ5, which resulted in this invalid blaster I argument. So I had to redo my autoexec.bat and config.sys to switch it back to IRQ2, but luckily after that fix everything worked like a charm. The drivers were loading up fine and I had no issues starting Prince of Persia with this beautiful Sound Blaster sound. Now another card I've been dying to try out is this digital to analog and analog to digital converter card with a serial-like port on the back. So this is something that kids nowadays do with Arduinos. Back in the day you had this interface card in your IBM PC, hooking everything up using a serial cable and doing your prototyping. with GW Basic nonetheless. So no Arduino online editor here. This is just basic code interfacing with this card, allowing you to read all of these channels and do digital to analog and analog to digital. So really fascinating. I was able to get this up and running because I still had the original floppy which had this demo program here, which just reads out all of the channels. And as soon as you hook up the wires, you can see that by turning the potentiometer on the prototyping board, you can see the values changing on channel 1. So I have the potentiometer hooked up to channel 1, and here you can see the value changing as I turn the potentiometer one way or the other. So yeah, really cool. I'll probably do a separate video on this one. And so finally we have one expansion slot left, and that's where I also left my inspiration because I really didn't have anything more to add to it. I did found this novel card here, which I think is kind of a hardware-based application serial, so you needed to have this card inserted into your computer in order to run a certain application. Obviously I don't have that application anymore, so it's not really of any use to me, but I can imagine that people did have this type of stuff in their IBM PCs back in the day. Now with all the expansion cards full, I could probably still add one more thing, and that is a second MFM hard drive. Now I didn't want to bother inserting another 10 megabyte Seagate MFM hard drive into this expansion chassis just for the fun of it, but it is technically possible to add a second hard drive. That's all I have time for today. So as you can see, the expansion unit is filled up completely with all possible expansion cards. I don't think I cheated that much. It's not like I put in 4 COM ports and 3 parallel ports and filled up the thing like that. I think every expansion card which is in here has its purpose. So I hope I was able to show you something that you don't typically see in a retro collection, because the IBM expansion unit is a pretty rare beast, and to have one which is completely filled up with expansion cards is, I think, even more rare. So I hope you've enjoyed this video. I hope you picked up a thing or two. If you have any comments, if you have any suggestions, please drop a comment. And if you've enjoyed it, please consider liking or subscribing to the channel. It would really help out, and I hope to see you guys very soon. Bye bye.